Hello everyone, I welcome you again to Simplified RSA. We are the guys who makes it look easy. Now, at this moment, I believe everyone is familiar with the difference between an equation and an expression, right? And we did some application whereby we were doing a previous question paper of some sort to show the type of problems that regards simplifying expressions. Let's continue on that today. And our selected topic for today is this one. Again, today we have to factorize the following expressions, and you have to factorize them fully as indicated. Now, we all know that we have different types of factorizing equations. You can factorize equations by taking out the common factor. You can factorize equations by grouping. You can factorize equations in different forms, like I say. With this one, let's go and apply. So, question 1.1.1, I am required to factorize this expression fully. I can approach this in different ways, but then the first common thing that I see is that on the first term and the second term, 4y squared and 16, I can take out a common factor of 4 because 4 is divisible here, 4 is divisible here again. If I take out the common factor of 4, I'm left with y squared minus 4, such that if I multiply this back, I would get the very same as given expression. But now, clearly, I can factorize this one further because I can see here I have a situation whereby I have difference of squares. Difference of squares, we now know that it's going to be a situation where you have ideally say a squared minus b squared, such that both terms can be squared like that. And to factorize this is just to write the first term as it is a and a, and to write the second term as it is b and b. And because it's difference of squares, you just write plus or minus on whichever side you choose. But then it should be such that if you multiply it back or FOIL it back, it's going to take you back to how it was there. And in this case, given y squared minus 4, I can tell that this is the same as y squared minus 2 squared, because 4 can be written as 2 squared as well. So it's the difference of 2 squares, such that the factorization of this would be y, and then 2 and 2, and then plus and minus. That's when I applied the differentiation. That's when I applied factorization using the difference of squares. So now, this means that for 1.1.1, I will have 4y and y, 2 and 2, negative and positive. Now, this is how we factorize this expression fully. This is how the factors are going to be. And it should be in a sense that when you simplify this back, when you multiply throughout the factors, you must be able to get the very same expression as it was initially. So that's it for 1.1.1. Now, 1.1.2, I am given an expression which is in the form of a fraction. So it is the top part, which is the numerator, and the bottom part, which is the denominator. And I have to factorize the expression fully. Again, I can attempt this by factorizing the numerator first, and then factorizing the denominator after, and then see if everything cancels each other there, just to simplify it to be in the simplest form, right? Let's look at this. So this is how I will approach 1.1.2. I have the numerator, which is x cubed minus 1, and I have the denominator given like that, x squared plus x plus 1. I'm going to start by factorizing the numerator first. On the numerator, I have x cubed minus 1. And I can tell that this is the difference of cubes. Now, to understand the difference of cubes formula, it's when I have a cubed minus b cubed in this case, let me just write that properly, minus b cubed, it's going to be equals to, if I factorize this, the steps that I have to apply here is, first of all, I write the terms a and b without the cubes, and then I show the minus sign here. So this is the first step. The second step is I have to then square the first one. So it's going to be a squared, and then I multiply both the terms. So, and I add it here. That would be plus a times b, because it's a times b, and then I add the square of the last one, which would be b squared. That's how you factorize the difference between two cubes. And as you can see on this one as well, one squared, one cubed, 1 to the exponent 4 is still going to remain 1. So I can assume this as the 1 could still be cubed as well, as you can see. Meaning, if I have to factorize this using this formula, I have, first of all, I'm going to write the two terms with a negative as it is x minus 1. Therefore, the next step is I will square the first term. Therefore, it would be x squared, and then I would add the product of the two terms, and then I'll multiply 1 times x, and then I will square the last one, which is 1 squared, like that. So I directly applied the formula for the difference of two cubes. But anyway, as you see here, if I simplify this, I'm just going to have x minus 1 is to x squared. 1 times x is just going to be plus x. 1 squared is just going to be plus 1. So when I factorize this part here, I will have this, meaning for the denominator, it would be x minus 1, x squared plus x plus 1, all over x squared plus x plus 1. Now, I would go on and say I have to factorize. Let me just remove this here. So moving from the first step to the second step, I've factorized the numerator using the difference of cubes, and then this is what I get. From here, I can see that I have a common factor between x squared plus x plus 1 and the one below here, meaning this will divide or cancels this. Then I'm only left with x minus 1. So from here, I can simplify this further. This is the fully factorization for the expression that was given. Therefore, 1.1.2 is answered like this. Now, this one, to factorize this, we're going to use the grouping method, right? Students can approach this as different as they want. One student can see that it has a common factor of y between the two terms, such that your next step could be as follows. X minus 1 plus, if you take y as a common factor here, you would be left with 1 minus x. And then from here, you can tell that there's something similar between this and this. The only difference is the signs. So here you have x minus 1, here you have 1 minus x. And for you to can try to manipulate this to look exactly like this, it would be to take out a common factor of minus 1 inside here. Let's do that. If we do that, we're going to have x minus 1. If I take out a common factor of minus 1, that common factor of minus 1 will end up affecting the plus 1 to make it a minus. So it's going to be minus y into x minus 1. That's what I've done. So I took out the common factor of minus 1. If I take the common factor of minus 1 and take it outside, because this was plus y, that plus y will now becomes a minus y because it has been affected by the minus 1 that I took out here. And if I take out minus 1, the negative x changes and becomes a positive x. The positive 1 changes and becomes a negative 1, like that. And at this point, you can see that we have a common factor of x minus 1 and x minus 1 between the two, such that If I take out the common factor of x minus 1, I would be left with, where there was x minus 1 is just going to be 1, minus where there was y into x minus 1 is just going to be y. So that's the first approach, which it can be expected from students. Another way to solve this, which is going to yield the same answer exactly, it would be if we have x minus 1 as given again, using the grouping method, someone may identify that I have x and minus x, which has a common factor of x, and rewrite this as x minus xy minus 1 plus y. It's given like that. So what I've done here, I just took this term, I brought it closer to x because you can see it as a common factor. And then we have that minus 1 there and the plus y there. Again, you can see that we have a common factor of x in between here, such that if I take out the common factor of x there, I would be left with 1 minus y minus 1 plus y. And then again, since we are using the grouping method, you can see that there is something similar between this term and this term, such that for me to can have this one outside here to be the same as this, it would be if I take out minus 1 again as a common factor from here. If I take out minus 1 as a common factor, I'm going to write the first one as it is. If I take out minus 1 as a common factor, I would have minus 1 into, now, minus 1, if I take out the common factor of minus 1 from here, I'm just going to left with positive 1. And then plus y, if I take out the common factor of minus y, it's going to be left as minus y. So that's how the new term is going to look, because I want to manipulate it to be similar or the same as this, such that I have a common factor of 1 minus y and 1 minus y there. If I take out my common factor of 1 minus y, I would be left with 1 minus y. Where there was x, 1 minus y is just going to be x. Where there was minus 1 minus 1 is just going to be minus 1, like that. And as you can see, this is the same as this. It's just that it is written in different forms. If I want, I can rearrange this and write it as x minus 1, y minus 1. So you can see, like, you can approach this whichever different way you want, but it will always yield the same answer for 1.1.3. So this is factorization by grouping method. So I can try to simplify this as much as I can, but at the end of the day, students are still expected to practice. Go through your notes, go through whatever material you have, and don't forget to watch more of our videos, because that's when we get to give you the context of how to apply, or rather, to be familiar with the exam type of questions. And don't forget to subscribe to our YouTube channel, follow us in all our social media platforms, and do contact us for private lessons, guys. We offer private lessons at a very reasonable price. You can contact us on any of the contact platforms here. You can either send us a WhatsApp or send us an email. At the end of the day, we are here for you. I'm Mr. Maimane. This is Simplified RSA. We are the guys who makes it look easy.